Good morning, class, and welcome to this lesson on uniform circular motion and centripetal acceleration. Today, we are going to be able to define the major characteristics of circular motion, which will include velocity and acceleration. So right now, this is going to be all conceptual, and we are just going to focus on what is circular motion and how does that relate to centripetal acceleration. So, first off, let's talk about this idea of uniform. I put up there uniform circular motion. And uniform circular motion, I was going to put uniform CM, means constant velocity. Constant velocity. So, we are going to be traveling in a circle at constant velocity. Okay? So, for this class, for the purposes of this class, it's always going to be constant velocity. We're not going to get into accelerating around the circle as well as accelerating inward, okay? So constant velocity, moving in a circle. Now, we are moving in a circle, so we need to talk about what the formula is for the velocity of a circle. I'm going to put little c for velocity of a circle. So velocity, as you recall, is going to be your distance over time, okay, distance over time. But what is the distance of a circle? What is that? What is that? So distance of a circle is the circumference. So the circumference over time. And if you remember from geometry, the circumference of a circle is 2 pi r circumference. And we're going to change this little t to big T. Big T stands for period. Okay? And period, I'll write over here, period is time it takes for one revolution. Okay? So capital T is still, this is still time, but it has a more specific meaning. It is the time for one revolution. Typically when we're talking about circular motion, we are talking about things that are going round and round over, they are revolving or rotating. They are revolving or rotating over and over. Okay, so typically if something's going round and round, over and over and over again, then the period is a time for one revolution. So we have the distance of a circle. If we look over here, this is the distance of a circle, and t is the time it takes to go from the starting point and go all the way back around and finish at the starting point again. So velocity of a circle is 2 pi r over capital T, which is time, period, for one revolution. Okay? So let's talk about something else now. Let's talk about, I'll change my colors here. We'll talk about centripetal acceleration. What is that? Well, centripetal acceleration, by the very meaning, says we are accelerating. We are accelerating. However, we just remembered from our circle here, I'm drawing another circle, that our velocity is constant. Our velocity is constant. So what does that mean? How can it be accelerating if velocity is constant? And the reality is, anytime anything moves in a circle, it is accelerating. Because remember, velocity is a vector, and every vector has two components: magnitude and direction. Magnitude and direction. So because velocity is constant, what we're saying is at constant velocity is constant magnitude. Okay? So if this thing is going 5 meters a second around the circle, okay, that means it has a constant speed around the circle. But the reality is, every single point along the circle, the direction is changing. Right here, it's going that way. Right here it's going that way. Right here it's going that way. So because the direction is changing, it is accelerating around the circle. over and over and over again. And so there's a common question with this. There's a common question that always goes with this, and it says, how many accelerators do you have on your car? On your car. And the answer to this question is 3. You have the gas pedal for positive acceleration, you have the brake for negative acceleration, and then you also have the steering wheel. Because the steering wheel can turn you, and if you are turning, you are changing direction, and if you are changing direction, you are still accelerating even if it is at constant speed. Even if it is at constant speed. So already, just by looking at this, I'm going back one here, constant velocity, this really isn't even a true statement. This really isn't even a true statement because it's really constant speed. We have constant speed around the circle. Over here, cross that out, speed is constant, but the direction is changing. Okay, so centripetal acceleration is anything moving in a circle. Now, let's go to the next page. New color. Let's draw another circle. Okay. Centripetal. Centripetal means center seeking. Centripetal means center seeking. So, what does that mean for the circle? If we are right here on the circle, that means we are accelerating towards the center. If we are right here on the circle, we are accelerating towards the center. If we're at the bottom of the circle in the 6 o'clock position, we are accelerating towards the center. 3 o'clock position, we are accelerating towards the center. So acceleration always points inward. Acceleration always points inward. It is center seeking. If anything moves in a circle, acceleration points towards the center of the circle. Okay? Now, more common questions here. Typically, you're going to be asked to draw, we'll do green. You're going to be given a circle, and the question is going to say identify the vector, the velocity and acceleration vectors. Identify the velocity and acceleration vectors. So we know that at any point along this circle that the acceleration is pointing inward now. Okay, so that's going to be the vector. However, velocity is not pointing inward. Velocity is the direction of motion. And so right here, if I'm saying we're going on the circle this way, velocity would be pointing down. Right here, velocity is pointing that way. Right here, velocity is pointing that way, and right there is pointing that way. Velocity, the velocity or the direction of motion is always tangent to the circle. So these are tangent lines at that particular point. I'll draw another circle right here just to be clear. If we were moving that way around the circle, velocity would be going in the opposite direction. Okay? So velocity is always tangent to the circle. When anything moves in a circle, acceleration points inward, velocity is tangent. Okay? Now, with that being said, there's another very common question you're going to be asked. I can almost guarantee it's going to be on your next test. Okay? And it's going to say something like this. There's going to be something going in a circle. There's going to be something going in a circle. We'll say it's a boy with a string attached to a plane or something. Okay? Doesn't matter what it is. It could be swinging a bucket of water. Sorry, I'm going to draw that picture a little more accurate because it's not really going in the same direction, is it? So let's draw that a little more accurate. So a little plane going around the center here. And the question is going to ask you, what will happen when the string breaks? So at this point on the circle, right here, this string is going to break. Okay? And it's probably going to give you 3 paths, 3 or 4 paths. Is it going to go that way? Is it going to go that way? Is it going to go that way? Maybe they'll even say that one. So A, B, C, D. So what is your guess? Pause the video for a second to see if you can guess it. And so the answer is B, okay? Not A, not C, not D, B. Because once that string breaks right here, nothing is going to cause it to accelerate. It has no reason to accelerate inward. And because it's not accelerating inward, the velocity will continue along the direction of motion. Remember this concept of inertia? This concept of inertia, that anything going in a direction will stay that direction. So inertia, things move in a straight line unless acted on by, I'm just going to put outside force, okay? Unless outside force. So because there is no more outside force, once it breaks right there, it's going to continue going straight. If you don't believe me, swing something around, swing something over your head in a horizontal circle and let it go. It's not going to curve around. It's not going to curve. It's going to go straight. Okay? So things are always going to move straight from the circle because that's where its inertia is going to take it. It's going to keep going in a straight line unless acted on by an outside force. Okay? So as you can see here, oh no, you can't see this because you haven't learned it yet. Centripetal acceleration, this is going to be our abbreviation acceleration. Centripetal, our equation is going to be v squared over r. Notice the units for v are meters per second and r are meters. So we have meters squared over seconds squared over meters. Cancel, cancel. We are left with meters per second squared. Meters per second squared are the units for acceleration. And just as a little tip here, notice we have on certain problems, I'm not sure, maybe not, sometimes they'll give you acceleration and they'll give you r, they'll ask for something else and you have v here, and remember that v is 2 pi r over capital T. So this equation could turn into, depending on the question, it could turn into 2 pi r over T squared over r, depending on what you're given and what you need to solve for.